Hola clase! Today we are learning to solve trigonometric equations and to give the general solutions. As usual, I will give you a how-to guide step by step and then we'll make an example together. In a previous video, we saw how to solve a trigonometric equation and get to a particular solution. But since trigonometric functions are cyclical, then trigonometric equations are going to have infinite solutions. And they are expressed as what we call a general solution. That will give me the pattern of all those infinite solutions. For our how to do this step by step, first we're going to solve as if to find a particular solution, what we did in our previous video. Then we're going to have to use the general solutions formula, depending on which trigonometric reason we saw in the equation, a sine, a cosine, or a tangent. So if I see a sine, then I will say that theta equals n pi plus minus 1 to the power of n alpha. If I saw a cosine, then theta equals 2n pi plus or minus alpha. And if there was a tangent, theta equals n pi plus alpha. And n is always an integer, where theta is all the possible angles that will fit in that solution, the infinite solutions, and alpha is the first one that I find when I inverse the trigonometric reason. And remember, this is just coming from what we know the sine and the cosine represent. If I've got any angle in the first quadrant, I'm going to find the reflection in the vertical axis to have the same sign. So I can go from pi radians, go backwards that angle, and I will find the same value for the sine. In the cosine, if I reflect the angle in the horizontal axis, or in other words, is from 0 to pi or any even amount of pi's, I go both frontwards and backwards, I will get to the same angle. This is what these functions are telling me to do, but mathematically. The last step, if asked to me, if needed, is to give solutions within a required interval, or in other words, from the infinite solutions that I've got, pick the ones that comply with some condition. Let's see that in an example. Here they ask me to find the general solution and the solutions in a range of 0 to 2 pi for this equation. Now, as you see in here, they are giving me decimals instead of fractions of pi in the equation, which means I will have a decimal solution. I don't need to use fractions of pi in this one. But the first step is to rearrange to leave the cosine alone and then to inverse the cosine. So I could have that x plus 1.571 equals the arc of the cosine of 1/3. If you do that in a calculator, that is 1.231. That means that I can get a particular solution passing the plus 1.571, subtracting to the other side, and that will give me x equals minus 0.340. Now I don't want a particular solution, I want the general one. So then, because the trigonometric reason that I saw in the equation it's a cosine, I would use that general solution formula. Theta equals 2n pi plus or minus alpha. Now remember that alpha is the solution that I get when I do the inverse of the cosine, the arc of the cosine. This 1.231 here. And theta is everything that was affected by the cosine. So in our case, theta is x plus 1.571. So I need to be careful on that, but once I identify those, I can substitute in here. And then I can pass this adding into a subtraction. And I got x equals 2n pi minus 1.571 plus or minus 1.231. Because they asked me for the solutions within a specific range, from 0 to 2 pi, I'm going to start substituting values of n. Remember, n is always an integer, and see what it gives me. If I've got n equals 0, then x equals minus 1.571 plus or minus 1.231. If you do that, I've got minus 2.802 or minus 0.340, which is this particular solution we found before. None of that is within range, so I keep on searching. N equals 1, and then substituting x equals 2 pi minus 1.571 plus or minus 1.231. If I do those operations, I get 3.481 and 5.943. Both of those are within range, so I keep on searching to see if there are any more. I substitute n equals 2, which gives me that x equals 2 pi times 2, so 4 pi, minus 1.571, plus or minus 1.231, and the first one of that gives me 9.7643, which is already over 2 pi, so I know that every other one will be above. That means that only these two are valid solutions in that specified range. So now I can give the general solution and list the ones that comply. So I will write it as the general solution, x equals 2n pi minus 1.571 plus or minus 1.231. And then if x is between 0 and 2 pi, x equals, and I'm just copying the results, 3.481 or 5.943. I boxed the answer, so it's always easy to find, and I'm done. Now it's your turn to go and practice. Thanks for watching.